Okay, I hope that everyone can see this slide. Okay.
Yes, can see.
Okay, so for today, before we start, let us recap what we have learned in the first day. Okay, let's go to the previous slide. Okay, so yesterday we have learned about the principal component analysis. But before that, remember there are a few requirements before we start with any multivariate data analysis. Yeah, so before we carry out any principal component analysis (PCA) and as well as cluster analysis, there are prerequisite requirements. So that's we have learned yesterday. Okay. So again, you have to know about the installation of the software. Okay, yang ni kita dah tahu kan macam mana. Okay, so I hope that you don't have any problem related to this installation. Yeah? And then I just want to remind, as far as I know, for this software SLStat, if you are a student, if you want to purchase a yearly, we call it a yearly license. It is recommended that you prepare your matrix card and then you can attach the matrix card. I'm not so sure are they still accepting this way, but before this it is given discount for student for their Excel stat license lah. It is yearly validity. Okay. So yesterday as well, we learned about the differentiation between the multivariate, univariate, and bivariate. Okay, since the topic that we are learning in this workshop is on multivariate, so we just have a simple sharing. Yeah, what are the results that you can display or you can carry out in order for us to show the univariate way, bivariate data, and then the last one is multivariate. So. As I told you previously, when I joined academia, what I have saw that the activity related to using the multivariate already been done by in environmental field. Unfortunately, for food studies, there are so many lacking information on that. And if you read publication related to food studies, if they are dealing with multivariate data analysis, most of it they don't really talk about the prerequisite requirement. They don't talk about how they choose they conduct the PCA. Why did they choose the significant variables? Yeah? And then have they covered or make a complement to the PCA analysis with cluster? Okay, this is the lacking that I found when I joined academia and when I moving from environmental studies to the food studies lah. Okay, so because of that, that's why in HeartLab proposed to have this kind of topic so that each one of you could learn a little bit more about this multivariate data analysis. Okay. So this is the prerequisite requirement that we learned yesterday. We have evaluation of missing data. Remember that we talked about if the missing data related to non-detected peak, for example. So usually if you send your result, your sample to other laboratories, and then that laboratories just put in a note ND, so that one will become one of indication of missing data, which is if there is ND, meaning that there is no peak at all detected, so it shall be noted as 0. Yeah? And then if there's also related to LOD, limit of detection, this is especially for laboratory who use ISO or have ISO 17025. Yeah? This kind of laboratories, usually they have conduct the method validation and verification. Yeah. And then we learned about proposing to use 0.65 time to LOD, yeah, when the results of the sample is present. Yeah. We need to know that when we talk about LOD, limit of detection, if the lab report as less than LOD, this indicate the peak found in the sample is present, but the concentration is below the detection limit. Okay, meaning that there is a peak, but perhaps the peak is can become equivalent to the noise sometimes. So that's why they propose to use 0.65 times ILOD. Yeah, and then we go to identification of removal of outliers. Okay, there are two ways of having why or how to choose whether you want to remove the outliers or you want to let it be. So if we are dealing with having high repetition of samples, like you want to build a database for one particular sample, so it's recommended that you remove the outlier, yeah, using box viscous plot. Okay, and beside of that, we also have Grubbs and Dixon test. That one as well, they will identify the outliers. Yeah? So you can remove the outliers using that method as well. And then we talk about if we don't have much of sample repetition, and then the outlier found in the sample repetition may assist us on or indicate that the data may indicate the characteristic of one particular sample. So outlier shouldn't be removed at this place at this time. Okay. Collecting adequate data set for multivariate data analysis. This is also, we use the KMO test, yeah, Kaysen-Mayer-Olkin test. So this Kaysen-Mayer-Olkin test getting involved with 0.5. Okay? If we have more than 0.5, this is indicate that the data is enough for multivariate data analysis. But the ideal one is if we can get up to 0.9. Okay, and then the last one, we conduct a performing assumption test of multivariate data analysis, where we try to treat non-normal distribution and then heteroscedasticity, and then as well as non-linearity. So we can treat them using transformation. Okay, so if we go back to the this is the just the explanation that we have learned. Okay, so if we are talking about this significant level, for example, you can choose 0.01 for 99%. This one is recommended for halal testing. But if we are talking about identifying contaminants, we can go significant level up to 0.05. So if we choose 0.05 as a significant level, that indicate the confidence level that we get is 95%, which is we 95% confidence that the result that we have is correct. So there's a 5% error. Okay. So what else? Okay, this is the normality, homoscedasticity. So we treat this also the non-linearity data using transformation. Again, so when we open Excel stat, we know we talk about this. Standardized n-1 is the most common transformation method that we can choose. However, there are lots of way of doing it. According to sample metrics, different sample metric will have sometimes specific transformation method that you can choose. For example, most of microbial study, the best transformation method is log transformation. Okay, but you have to test in the individual sample. For example, when I did my study related to gelatin using this amino acid, standardized n-1, and sometimes Pareto can become the best, what we call that one, the best transformation method for gelatin matrix. Okay, so in this case, you have to test first whether it is suitable or not. Okay. Then we conduct the hands-on on prerequisite multivariate data analysis. Okay, and then we have this data that we have. Okay, so we conduct this evaluation of treatment, identification, removal of outliers, and then identify whether the data that we have is enough or not, based on KPO value. What else? We learn about the PCA, principal component analysis. So from here, we talk about if we have 13 variables in PCA, they will create uncorrelated data loading. we call it principal component. So numbers of variable will be equal to numbers of principal component analysis that we generated. Yeah. And generally, there are two principal component analysis will be considered for PCA, which is both of these two. Sometimes we call it F1 and F2. The one which bring the most explained data. So we have axis X and axis Y. So now we went yesterday also to the part of how do you want to check whether the variable that you have having a positive or negative correlation, and which variable having no correlation at all. Yeah? And then based on this PCA, we also can plot an observation plot. So observation plot is a sample plot actually. So any samples having the similar characteristic of variable will be located together. Okay? And then if we superimpose the variable plot onto the observation plot or vice versa, so we can get a biplot. So by having this biplot, we can confirm, or we can deduce that some particular variables may characterize one specific source of samples. So any variables that falls onto the group of the samples in the biplot will indicate that variable is characterizing mainly on the sample itself. Okay, so this is what we have learned in PCA yesterday, and then some case study related to halal fish feed. So we call it any animal that been given or feed with the we call them bad feed, yeah, something which is a filthy feed, such as sometimes they give the chicken manure, for example, or sometimes with a porcine based animal, so that we want to become a jalalah animal. Okay, so there is a study from UPM, so they prepare fish feed formulated together in the fish feed with the porcine or with the lard, the oil from the porcine, yeah. And then they able to produce a table. So this table we have two PC, yeah, the most highest PC that bring the most data. Yeah. From here, we can get the factor loading. So we talk about factor loading can be divided into three groups. Yeah. So the first group is if the factor loading is more than 0.75, that indicate the variable that having this factor loading is the significant one that may characterize the sample source. Yeah. And then if we look at the variable plot of this fish feed result, we can identify which variable, or in this case the triacylglycerol, yeah, which triacylglycerol is characterizing the fish feed having palm oil only, and then which variable or which triacylglycerol will characterize the fish feed containing lard, and which which variable or which TAG, triacylglycerol, characterize the mixture of palm oil and lard in the fish feed. Okay, so you can see on this side, and in the middle. Okay, so we can trace according to this PCA. Okay. Then we have this hands-on. So the hands-on that we talk about the McDonald's menus. So from the McDonald's menus, we can explain about how these nutrients being analyzed, yeah? Energy, protein, carbohydrate, fat, and saturated fat. Yeah. So from here, we can identify which menu having high energy, high protein, carbohydrate, fat, and saturated fat. Okay. So from there, we move to cluster analysis in food studies. Sekejap ya. Saya kena tutup saya. I have to switch off this WhatsApp. Okay. Okay. And then we move to cluster analysis in food studies. Yeah. So we talk about what is the function of cluster analysis. Yeah? It will group the sample itself into a specific group according to the distance measured based on the parameter that we have or variables that we have. Yeah. However, for this cluster analysis, data set transformation is recommended. Yeah, as far as we talk as well. We want to ensure that we follow a better prerequisite requirement. Yeah, compared to some of the papers, they just go on conducting classification method or cluster analysis without doing any pre-processing the data set. Okay, so classification method or cluster analysis, generally, if we conduct PCA at the first place and then supported by this cluster analysis, they will complement each other. So you may compare your results, and then from there you can deduce the give the we call that one conclusion from your study. Yeah. So this cluster analysis will produce two results. So we have dendrogram. So from this dendrogram, we will get the horizontal line. Yeah. Horizontal line here will that cross the vertical line indicate number of groups that being done given by the cluster analysis. However, to get this group, there are two ways. You can let the system to give you the group automatically, or sometimes we can request or we can push the system cluster analysis to produce numbers of group that you are looking for. Okay, but from there you have to investigate one by one which group is the best, which is complement with the PCA's results. Okay, and then from there we get another plot. We call it a profile plot. So in this profile plot, they will show you which variable is the we call that one dominant or less dominant or moderate in the each group. Okay, using this profile plot. Okay. Then we have the hands-on cluster analysis. Again, we use the McDonald's menu. Yeah. So we perform the cluster analysis. Okay. So again, yesterday in the cluster analysis, we conduct twice cluster analysis, which is in Excel step. We don't name as cluster analysis, but we name it as the agglomeration hierarchical clustering (AHC). So we show to you that how we can conduct AHC or cluster analysis in automatic mode, and then we push the system or we tell the system we want 10 groups. Yeah? So the results that we get yesterday or we got yesterday can be complementary to the PCA. Okay, so that's the end of yesterday's what we have learned. Okay, so I hope that you can recap all of this. Yes, anybody want to ask question?
Dr. Shirwan, we got two questions.
Yeah.
From first from Sister Izzat. Salam doctor, to purchase the SL stack, there are basic and basic plus, applied and premium package. Which one is suitable? It is basic package enough? Thank you, doctor.
Okay, as far as I know, basic for you to learn about this today's topic, this in this workshop, it's enough with basic actually. Yeah. But as far as I know, you have to prepare with your, if you are a student, your matrix card, and then you can get a discount. Yeah. Previously, I think previously when I purchased, the price is only $50 for student. So you have to check on that one. And then for lecturers, perhaps they will be increasing. Even the software allow you to purchase a perpetual version, meaning that one time purchase, and then but that one will be expensive. Okay. Okay. Another question. You have to open your mic.
Okay, second one is from Sister Suryati. Assalamualaikum doctor, can we use the PCA to model the reduction or retentions of analytes? Example, the reductions of fatty acids in sample caused by heating treatment.
Okay, actually yes, no problem actually. But if we carry out what do you call it one? You have to put a design first. If you really, if you really want to, we call that one, to do that one, I prefer that we can discuss further because there's lots of designing on the experiment first, and then we can choose whether we want to use PCA or just simple comparison between treatment. Yeah, sometimes we don't really need PCA. If the aim of our study can be clearly described in another simpler methods. Yeah. But if you really want to me to assist you, I think we can go further for the discussion lah. Yeah? So perhaps you can contact me later so that I can share or suggest you which is the best. But correct, we can still carry out PCA to any data, yeah? Including the one that you asking. Okay. Any question left?
That's all so far.
Okay. So since there is no question, but keep in mind this video for the second session is also recorded. So we will bring you to the I will call that one giving you the link, and in my case I have uploaded this video to my YouTube, so you can watch from there as well. So for today, we are going to go to the next part, which is we call it discriminant analysis in food studies. Yeah. So discriminant analysis is both an explanatory and predictive technique. Okay. Bila kita sebut, or when we talk about explanatory, meaning that it is almost similar with the PCA. Yeah? They can explain using discriminant analysis. Together with that, the good with discriminant analysis, it has a feature to predict your sample. Okay, I will show you, but it will be qualitative prediction. Okay? Discriminant analysis, what I mean is qualitative prediction. Okay, for example, I have the same data that we have. For example, we have, okay, I think we have this data itself. Okay, for example, I prepare a palm oil fish feed, and then I also prepare a palm oil fish feed containing lard, and then I also prepare a fish feed containing mixture of lard and palm oil. Okay, so this one we call it training data set. Something that we have prepared, and then we analyze the triacylglycerol. Okay, we analyze, this is the triacylglycerol, the variables. So from here, by using this this is testing. Okay, by using this grouping, so you can see the group of palm oil, lard and palm oil mixture, and the last one is lard only. And then we carry out the discriminant analysis. So the system will keep it as a database. Then I analyze one fish feed, which is I know what is the content of that fish feed, but I want this discriminant analysis to predict whether is this fish feed containing palm oil only, palm oil and lard mixture, or lard only. So discriminant analysis have a better or has an advantage compared to PCA because they have the features, they can predict the unknown sample that you have. So that's why we call it, they have a predictive technique. PCA doesn't have it, but it is qualitatively. We want to predict the group. We don't predict how much the lard and palm oil content, but the group, whether it's palm oil plus lard, or palm oil or lard only. So that's why we call it qualitatively. Secara kualitatif, dia akan menentukan ataupun menjangkakan predict sama ada sampel tersebut, fish feed tu, makanan ikan tu adalah daripada sumber kelapa sawit ataupun kelapa sawit bercampur dengan lard ataupun lard sahaja. So that's why we call it qualitatively. So this is the ability of discriminant analysis. So what will people do? Generally, if we are doing any research, we go for PCA to explore the data. But when we want to predict, we go to discriminant analysis. Same goes if you really don't want to go to study about PCA. You rasa kalau macam tu tak nak lah buat PCA sebab I nak predict sekali. You can go directly to discriminant analysis so that you can explore. Together with that, you can predict. But provided with that, you need to follow or fulfill the requirement of a prerequisite that we learned yesterday lah. Tetap kena buat that transformation, those removing or treating the outliers, removing the missing data, and so on and so forth. So make sure you carry out that one if you and before you conduct the discriminant analysis. Okay. So this discriminant analysis will validate the grouping by cluster analysis. Okay, sometimes people want to have some flow of research, so they go for PCA, and then this PCA will be validated by cluster analysis, and then can be revalidated by the discriminant analysis as well. So that's why this is the ability that the discriminant analysis being used to validate cluster analysis. And then this DA can confirm the significant variable that contribute to grouping, meaning that if you have a PCA, you know which variables are significant one based weak and moderate, or significant, moderate or weak based on factor loading. So by conduct an individual discriminant analysis will also select the significant variable as well. So you can compare between the significant variable in PCA and as well as the DA. Yeah. And from here, we can, since the DA has the capability of prediction, so that's why we call it DA can authenticate the group of unknown samples. Yeah, so this one is complement this one lah. Yeah? This authentication of the samples. Yeah? However, before we go for this predictive technique, we need to have a training data set. Inilah training data set and testing data set. So training data set is data set that you want the discriminant analysis make it as a database. And then a testing data set is the data set that you already know the concentration or the content, but you want to check whether the content that you prepared are correctly predicted by the discriminant analysis. Okay. So this is the good of discriminant analysis lah. Beside of discriminant analysis, we can also have some talk of algorithm, which these features we call it partial least square discriminant analysis. Okay, sama sahaja the concept, they still discriminant qualitatively, but they use different algorithm lah. Yeah. So from my experience, I try to I conduct a gelatin analysis, and then I compare whether to use PLS, partial least square discriminant analysis, and discriminant analysis only. The good thing is discriminant analysis have a better prediction ability compared to PLSDA. Okay, but in this case, what I'm going to propose, if you have different way of this discriminating your sample for authentication sample, for example, it is good if you have different features. Try to compare first, and from there you can choose which discriminant analysis model is the best lah. Instead of just follow what are previous people studies lah, without you conducting your own discriminant analysis test. Choose dia ada macam-macam lagi discriminant analysis punya cara. So ambil banyak-banyak tu, try to conduct discriminant analysis and then compare the result. From there you can choose whether what is the best discriminant analysis for your samples matrix lah. Okay, so this is my recommendation for those yang nak buat multivariate data analysis. Sometimes it's very hard for you if you just simply follow what other people are doing without knowing why they choose that particular of test lah. Okay, so by using the training data set from the PCA, I told you we can make a flow of studies and cluster analysis, which is CA. We can confirm the correct classification of the grouping because PCA and CA, they will produce a group. So you can use the discriminant analysis to confirm the classification. Okay, confirming of classification is by looking at the percentage of correct classification provided by the DA itself. Macam mana rupa dia? This is the correct classification lah. For example, you have fish feed lot, which is total yang you prepare is 9, and then you conduct this DA what is the prediction result. So you can see you have total 9 of fish feed lard containing lard, and the DA able to predict the lard, 9 of the lard is lard, lads macam tu. So that's why they call it 9/9 dapatlah 100%. Same goes here, you prepare lard and palm oil macam ni, tengok yang ni. Okay. Contoh yang ni, lard and palm oil, dekat sini ada, kenapa dia pusing situ? Okay. Sekejap ya. Okay, yang ni lard and palm oil mixture ada 27 for example lah. Okay. So from here, can the DA predict all those 27 lard and palm oil are a mixture of lard and palm oil? Yes, they got 27. This is the prediction result. So that's why they get 100% correct. Yeah. Same goes with this one. We prepare a fish feed containing palm oil only. Numbers of them are 9. So the discriminant analysis able to correctly classify 9 of them are really from palm oil. So 100%. So they have an average. So the average of the discrimination model ability is 100% ability to make a correct classification. So this one will support your results. Because beside of that, you have to ensure the Fisher distance test at 0.05 or 0.01. Yang ni depends on your study lah. For this one, again 0.01 is recommendation for or recommended for your halal testing lah. For if you are going to use contamination punya studies, your purpose is for contaminant, you can go up to 0.05. Okay, you can see here the Fisher distance between the grouping are significantly different. Is also indicate this model able to differentiate different group of samples. And then at the Fisher distance, they will provide as well the p-value. Any p-value lower than 0.01 indicate the grouping are distinct and confirm the significant variables lah. So the p-value less than 0.05 or 0.01, in this one again yang ni pun bergantung dengan you punya selection of confidence significant level. Sepatutnya yang ni kalau if we choose this one 0.05, it should be 0.05 lah dekat sini. If this one is 0.01, this one should be 0.01 as well. Okay, so perhaps this one typo. Okay, so the p-value that you have set for weeks lambda test will indicate the rejection of hash null. We will look later what is the hash null for the weeks lambda test. Hence the grouping are significantly different. So there are 3 requirements to confirm that your data are really able to become a good database, and the discriminant model that you develop able to correctly classify your sample qualitatively. Okay, so from here, the first one is confirm from correct classification like this, and then your Fisher distance test should be have a significant difference, and then the p-value should be less than 0.01 or 0.05, and then you also have weeks lambda test. So weeks lambda test shall show you less than 0.05 or 0.01, depends on your selection of significant level. Okay, so from this result, the DA has successfully developed a discriminant model. So this is the basic principle of discriminant model. Okay, this is the one that I told you, the p-value. P-value of Fisher distance. You can see here, lard and lard is 1. So memang we want to confirm lah, lard and lard should be 1. Meaning that they are correctly in that particular group. But lard group and lard mixture with palm oil are less than 0.01, but this one, the result that they give is less than 0.0001. That indicate lard group and lard and palm oil mixture group are totally distinct from each other. Again, this one, lard group or lard cluster and palm oil fish feed clusters are also distinct because of the p-value that they produce is less than 0.001. The one that they identify is less than 0.0001, which is far more distinct that we said. Okay, so sama jugalah this one, the grouping. So this is one evidence to show that your discriminant model able to differentiate grouping qualitatively. Okay, another one we have Weeks lambda test. Okay, this is the hash null. Okay, hash null of this Weeks lambda test is the means vector of three classes are equal. Okay, meaning that the direction or the grouping is not different as well. It's not distinct. Okay? So the alternative hypothesis, at least one of the means vector is different from another. Sekurang-kurangnya, one of the group direction is different from another. This is what we are looking for actually. We want the grouping to be different. We want the model to be able to discriminate all the grouping should be different location, for example. Okay. So now you can see the Excel stat carry out the calculation. Yeah. From this calculation, they calculate the p-value. Yeah, but this one the p-value that we have set 0.05, but the p-value that the discriminant model able to produce is less than 0.001. So look back at the definition as the computed not definition, the interpretation as the computed p-value is lower than significant level 0.05, which is this one. Okay. One shall reject the null hypothesis. So kita akan reject null hypothesis ni, which mean apa? At least one of the means vector is different from each other, from another. Indicate memang the groups of lard and palm oil mixture and palm oil only are different because they kata different from each other. Okay, so this is an indicator that your discriminant model able to differentiate type of sample that you have. Okay. Then the unidimensional test of equality of the mean of the class identify the significant variables in the study. Okay, from this discriminant analysis, you can find one table in the Excel stat which is named as this one. Yeah, unidimensional test for equality of the means of the classes, where okay, the discriminant analysis will list down all the parameters that or variable that we chose or that we have in the training data set, which is in this case TAG, triacylglycerol. Okay, and then they will calculate the lambda, F statistic, and P value. So what we are looking for is those significant variables or TAG having high or highest F statistic indicate that variable is the significant one that discriminate or that assist the discrimination of the samples. Okay, so what you can do, you susun saja this F statistic according to from the highest value to the lowest one, so you can identify which variable are having the or the significant one that discriminate the samples, the grouping. So in this case, kita tengok yang ni. We have PPL, one of TAG. You can find the whole name of this TAG. Nama dia panjang lah, so I just simplified as PPL. So this PPL, you can see the F statistic value is 78.96. So that indicate PPL is the most significant variable or TAG that able to discriminate those palm oil, lard and palm oil mixture, and lard grouping or clusters lah. So yang ni you boleh susun, so you can see lah which one. Another one, first susun the F statistic. The second one, since we have set up the p-value, which is 0.05 or 0.01. Okay, but this one, this example, I just choose 0.05. For example. So you can arrange this one as well. So you can see any value less than 0.05. Okay, this one, no. This one, yes. Yes, no. Yes, 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 no, and yes. So out of these variables or TAG, 3 of them are not significant. So that will indicate in the future, if you want to discriminate or you want to authenticate your samples in the fish feed, you don't have to analyze CT2, you don't have to analyze OOO, you don't have to analyze LLN, which indicate you can save more time of analysis, you can save more money instead of for purchasing of the chemicals and standards. And that one, if we use this method as a what we call that one, for enforcement case, untuk kes-kes penguasaan, JAKIM for example lah, ataupun those people from kementerian, some kementerian punya levels, so you can propose to them, okay, just analyze this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables only to discriminate whether the fish feed containing lard or palm oil or lard and palm oil mixture. Okay, so this is helping when people are asking, so what is the contribution of your study? You boleh cakap up to this level lah, yeah. Your study, your method able to identify the significant variables, and then you can propose to enforcement agencies to choose or analyze these variables only, so that we can save time, save money, save cost for the government for their enforcement case. Kita tahu when we stay in any countries, they are obliged to have a proper methods of analysis for untuk menjaga keamanan negara lah, contohlah ya. So by having this kind of method, you can propose to the agencies or any government agencies so that this will assist us to save costs, at the same time saving the countries as well. So this is what I've done in the Department of Chemistry between 2006 and 2013, 7 or 8 years. We use this multivariate data analysis to identify any oil spill that being spilled by the container and even from the shipment of oil around the world yang lalu dekat kita punya perairan Johor. So when there is an oil spill there, mungkin ada pelanggaran ya. So from we take samples from the air laut together from the ship itself, and then we try to analyze we analyze with GCMS, and then we identify the biomarkers, and then we use this discriminant analysis to support the result, and then we go to court case, and in the court case I make a testament that whether one particular company or three owner of the ship are responsible or not. Okay, so by using this multivariate analysis, it will assist us on giving a good decision. So kita tak simply make a decision without conduct any and without baseless testing. Okay, so this is the advantage of having multivariate, especially if you are using discriminant analysis now. Okay. Together with that, we talk about discriminant analysis. Okay, we say that DA, discriminant analysis, has the predictive ability. Okay, so in this case, we have to analyze an unknown sample as a testing data set, and then we can predict the unknown samples lah. So this one lah, ya, sebenarnya I want to show this one. You can see to this slide. The previous slide. Okay, this one actually. We have prepared all those fish feed containing of palm oil, lard and palm oil as well as lard. And from here, we know what this fish feed containing. But we want to check how the discriminant model able to confirm whether this is a palm oil, lard and palm oil mixture, and or lard only mixture. Okay, so that's why we get this result. So they will bring you to this plot. So we have observation plot. So you can see the lard and okay. The blue color here, this one, yang lard ni, this is the testing data set. Lard and palm oil also, these are testing data set yang kita jadikan, that we make it as a database. These three, yang ada tanda square, this is the prediction. So you can see lah, this is the group. This is lard only. this is lard and palm oil mixture. This is palm oil mixture only. Okay, so you can see sometimes they are still having an overlap, but you can see the group is here, and this group is here, and then it's here. Okay, so you can see the grouping itself. If we make a simplified result, we can see lard and palm oil are distinct places. Makin jauh, those grouping is better. Maksud dia kena lagi jauh lah sepatutnya. Tapi from here you can see the DA able to predict samples in observation plot, but bear in mind at p-value less than 0.05. Meaning that they still allow 5% error. So in this case, unfortunately, when we conduct this test, they choose p point less than 0.05, which is in my recommendation. If we are talking about halal, better to choose 0.01, or even you can go 0.001. For that, you can make sure you have 99.9% accurate result. You still allow error, but very small amount of error. So you can see if we put 0.05, you can see here, because of that there is a possible overlap, lard and palm oil. From this group that falls to palm oil group. Okay. So this one, this is the one that the result of discriminant analysis, the predicted one. This one is the one that we prepared. I just simply label as P1 because I know the content, but I just want to validate. So you can see P1 is palm oil. LP, which is mixture of lard and palm oil. So you can see all of them are correct. And then lard is L5. All of them are lard. So this is the correct classification from the discriminant analysis model that you have developed. Okay, so before we move to hands-on, kita nak try buat. Ada soalan tak? You have any question?
So far no.
Okay, so kita try. Let me show first to the. Let us go to the folder where we keep our data. Okay, so this one for today, the discriminant analysis hands-on, we go to discriminant analysis folder, file, number 6. Okay, sekejap ya. Before that, let us go to the PowerPoint back. Okay, because this time I am using a new data set. We don't use the McDonald's menu sebab macam tak sesuai. Because for discriminant analysis, so we go back to the PowerPoint. Okay, let me explain first about the data. Nampak PowerPoint? Okay. Nampak? Okay, so if you can see the PowerPoint. Okay, so the data that we have here, we call it large scale of multivariate data. So you have to take note on the explanation during the hands-on. Okay, so this large scale of multivariate data, this is the explanation. So the data provide a detailed information on packing, atmosphere, total mesophilic aerobic flora, lactic acid bacteria, and process variables of 70 samples of poultry and beef sausage produced industrially in 2017. Okay, this one actually is the data that we use for that treatment of missing data yesterday. Okay, but this one we want to explain more a little bit. So we will conduct a discriminant analysis. First, you have to open the file number 6, discriminant analysis, and conduct transformation. but I think I have conduct the transformation at the first place, so tak perlu pening-pening lah. And then we need to add a class at the column. And then at the last column, we shall label the sample according to poultry and beef. And then we will choose analyzing, go to Excel step, we will choose to analyzing data and then discriminant analysis feature, and then select variable from pH until old cheese, and then select variables with p-value less than 0.05 only. That is the first step. So mari kita pergi, kita buat dulu. We go back to our Excel. Kita dah discriminant analysis. Okay, so this one I have opened up the result, the data. Okay, so apa yang kita nak buat? First, add class, conduct transformation first. So this one, this is the original data. The first sheet is sample data dash remove ND. This is the original one. Okay, now we need to go for transformation. So go to the next sheet is the sheet is variable transformation. This is the transform data that I have correctly done for you. So tak perlu pening kepala. So because we want to know how the discriminant analysis is carried out. So variable transformation is already done yesterday. So we don't want to repeat the step. So ambil saja yang yesterday's punya data. Now dia punya arahan dekat sini, what we should do, add a class column at the last column of transform data. So this is the transform data. Go to the last column. So I already label as class, and then this is the poultry. Macam mana I tahu? Memang dia poultry, I memang tahu sebab I ambil data ni lah. So because this is, I want to make it as a training data set. So as a training data set, we should know what the sample that we have lah. Sebab kita nak jadikan dia, we want to make it as a database. So we shall know what the sample is. So that's why this is a poultry sausages. And then the bottom one, starting from B, 01T0A, this is the sample. So starting from this, until to the last column is the beef sausage. Okay, so this one we need to label. Okay, again, we are conducting discriminant analysis that able to do it qualitatively. So that's why we put poultry. Kita tak letak 1% poultry, 2% poultry, no. Because that is quantitative. This one is qualitative. So label the group only. Poultry, beef. Okay. So we want the discriminant analysis model to use this training data set to differentiate whether the sausage that we have is poultry based or beef based. As if macam ni. Kita ada sampel sausage dekat pasaran. Kita nak sometimes sausage tu dilabel secara mislabeling. Sepatutnya itu ayam tapi dicakap lembu, ataupun sepatutnya itu lembu dicakap khinzir, contoh lah ya. So mislabeling. So we want our create a method so that it will assist the enforcement officer untuk buat enforcement activity. Pergi dekat mana-mana shopping mall or even those people that selling sausage, take that sausage and then run some of the tests. For this one, they conduct pH activity, they check on the oxygen level, aerobic flora and those and everything. They try to see whether it's able to identify what are the source of the sausage, sama ada dia poultry ataupun beef. Walau bagaimanapun, actually secara realitinya tak perlu pun buat all these variables. You buat je lah PCR. Find the DNA whether you have chicken or beef. But in this case, because we want to learn about discriminant analysis, based on this variable that we have, can the model from the discriminant analysis able to differentiate whether it's poultry or beef? So this is what we are going to do lah. Secara mudah dia, buat apa nak susah kan? Analyze with GCMS semua ni. Baik, you buat pakai PCR teknik saja. Okay. So that is what's behind lah. Okay. Okay. Now, kita dah dapat this data. We want to create a discriminant analysis. Okay. Go to Excel step. Open up your SL stat icon. Okay. Then go to analyzing data. Click discriminant analysis. And then you will get this features lah, dialog box. Okay, again, go to your Excel stat, click Excel stat icon, go to analyzing data, choose or click discriminant analysis. Okay, so you akan dapat this folder, sorry, the dialog box. Okay, so you can see the first one is y/dependent variables. So this is the dependent variable is your grouping, your class ataupun grouping lah. So click class title, drag down to the last row of which is the beef lah. Macam tu. Okay. Then settle dekat situ. Okay. Now you see there is an X and explanatory variables. Again, click this one. Go to the title of the PH reading. Drag to the all cheese title and then drag down to the last row. Okay. So since this is oh, I'm sorry. It should be quantitative kan? This one quantitative. But the Y is qualitative. Yeah? The X is quantitative. So now you have to choose sheet. And then for variable labels and observation labels, make sure they are ticked. Kita kena tick this box. And then for observation labels, choose the sample's name. Starting from sample title, drag down to the last row, which is BO2T2C3. So yang B kat depan tu maksud dia beef lah. Okay, sampai situ. Then go to options. Okay, I ulang balik lah ya, takut terlepas. Okay, again for Y dependent variables, you can see it is qualitative because discriminant is for qualitative purposes. Click that one, go to class, click class, drag down to the last row, beef. And then for X, which is explanatory variables, you have to tick the quantitative box. Sebab data kita ni quantitative, we have the value, numbers value there. Okay, so choose starting from the title of PH reading, drag to all cheese, and then drag down to the last row. Okay, done. Make sure you choose sheet. Yeah. Or sometimes people will be asking, okay, kenapa ada range? Why we should choose sheet? Why we don't choose workbook? Lupa nak sebut. If you click range, you can click any cells dekat bawah ni, dekat below of your Excel. So your result will be appear at that bottom, at the place that you tick the range ni lah. Kalau you choose range sini. If you choose sheet, your result will appear as a new sheet macam semalam lah. If you choose workbook, your result will appear in a new Excel file. So kita macam tak nak susah-susah, we go for sheet lah. So when we go for sheet, you will got a new sheet as a result lah, DA kat sini lah. And then dah sudah yang ni, go to options. For tolerance, just maintain 0.001. Okay, you have to click equality of covariant matrix and prior probabilities. Okay. Then significant level ni you boleh letak 1% ataupun kalau you nak buat 5% pun boleh. So dalam this case we put 5%, which is 0.05 lah. Kalau you buat, if you are using for halal testing, you can go up to 1. So again, I recommend 0.05, but it's up to you. Okay, so and then go to validation. Validation DB, jangan klik apa-apa. Click nothing there. Prediction as well, we don't want to predict at this stage. Belum lagi, kita tak nak predict lagi. Okay. And then you want for missing data, remove the observation or estimate missing data, just use remove the observation. Because at the first place, we already conduct transformation, so sepatutnya memang tak akan ada issue lah. It shouldn't be any problem with the data itself. And then for outputs, click each of box. Klik je semua. And for charts, you have to click all of it. Semua click, and then for number of observation, you put 10,000. Okay, why is this important? Yang ni penting. If your data is so much, too many data, but if you keep as 1,000 or 100, so only the first 100 data will be analyzed. So you put as high as possible. So in this case, we have decided to have 10,000. You can go up to 100,000, for example, kalau your data is very big. Okay. So after this, go to OK. And then click, okay, so you can see here, selection of name, Y is qualitative, which is your grouping. So you have 70 samples of sausage, mixture of poultry and beef. One column only, sebab memang this is the column, one column for Y. And for X, you have 0 row, but one column. And then for observation levels, you have 70 and 1. Sekejap kita pergi balik. Sekejap. Oh, patutlah. Okay, silap. For X ni, you have to choose this one. Yang tersilap ni. Sepatutnya dia macam ni. Okay, done. Check balik. Okay, you have to check this one. This one should be sheet. Okay, and then okay. Betul. X, you have 70 rows and 18 columns. So 18 columns indicate you have 18 variables. And then observation levels, you have 70 in one column, that's about one sample column, and then you have 70 samples. And then you click continue. Okay, so when you click continue, you will get this kind of results. So this one is the result that you create. Okay, the one that I have made a note for you is the DA. So you open the DA, yang ni I have made the note for you lah, for this workshop. So we can go one by one, starting from summary statistic. This is the descriptive statistic. How many meat type of sausage that you have? You have beef is 32. You have sausage, for poultry sausage is 38. So the percentage is here, 45% and 54%. And then you can see the variable that you have. We have 18 variables. So pH reading up to all cheese. So this one you can see number of observation with missing data, minimum and maximum. Okay, this is mean and standard deviation. Okay. And then correlation matrix is this one. So correlation matrix is similar that the one that we learned in PCA. That's why I'm telling you the discriminant analysis also have the similar characteristic of PCA, but with additional tasks that they can provide, which is predictive lah. So discriminant can explore your data as well. So based on this correlation matrix, so you can use this selection lah. 0.7 up to 1 is strong correlation matrix. 0.3 to 0.7 is moderate, and the last one is 0 to 0.3 is weak. Okay, so this guideline depends on type of study lah. Okay, so some people they have one particular correlation metric in their study field, so they have to follow. So in this case, I bring forward this 0.7 to 1 because I didn't find any correlation matrix guideline for food. Unless people just say if you can get R up to 1, that is the best lah. But we want to have this strong, moderate, and weak so that it's able to us to choose which variable or which parameters are strong. So bergantung dengan bidang masing-masing lah. Okay, so this is variable that we have. Sekejap, kita tengok ni apa. Okay, apa dia punya explanation? Oh, ni tak ada apalah. Okay, correlation matrix. Oh, this one is individual correlation matrix lah. Untuk yang ni, for this one, this topic. For this topic, this is the explanation is here. And then we move to this one. This okay. After carry out getting the results of descriptive analysis and correlation metrics, now we jump to, or we reach the discriminant analysis results. Yeah? So you can see there is a means by class, yeah, which is indicate the mean of each variable in each class. Kan kita ada variable these variables ni, this variable. What is the mean value, parameter value for each class lah. So this one. This one. Yeah. This is the average mean. Okay. For each variable in each class, in beef and poultry sausage. Yeah. And then you can have a sum of weight, prior probabilities and logarithm. Okay, this one tak issue pun sangat. Okay, but this one we have multi-collinearity statistic. Yeah. This table identifies the variable responsible for multi-collinearity between variables, which is variable that having a already correlation at the first place. In some studies, they don't want to have multi-collinearity between variables. But in science, it is acceptable because you don't remove any variable that having correlation. So when the variable tolerance is set lower than set tolerance, this variable is identified as responsible for multicollinearity. The default tolerance is 0.001. This one we already set in the Excel discriminant analysis features. From this multicollinearity statistic, they will produce a result state as VIF, variance inflation factors, which is an inverse value of tolerance, which is VIF equal to 1 over tolerance. So you can have 1 over tolerance to get a VIF. Okay. So you can see here, when the variable tolerance less than 0.01, that indicate that variable having a multicollinearity. So when you can see here, ada tak yang lower than 0.001? Tak ada tak ada. So no multicollinearity in your or in our data set. Okay, and then we can have this between class SSCP matrix. So the SSCP matrix means sums of square and cross products, which are proportional to covariance matrix. This SSCP is used in calculation and check the following relationship: SSCP total, SSCP intercorrelation, and plus SSCP intra-correlation total. But this one is for statistical approach saja lah. So what we are looking for is not here yet. So we have pool within class SSCP metric. This is also still a calculation. Okay, this is the total sample SSCP metric yang dia akan calculate to get this result. Okay, I think I should go to the lower part. This is still the same. This is the one that we are looking for, similar that we explained in our PowerPoint. So we have a Bok test, chi-square asymptotic approximation. Okay, this Bok test is used to test an assumption of equality for intra-class covariance matrix. Intra-class mean within classes. So we have two classes here. We have bovine and also we have porcine. We want to have to see, is there any equality for intra-class covariance matrix? Ada perbezaan tak between the variance of the matrix lah, variance between the data you have in the group. Two approximations are available, one based of the chi-square distribution and other one on Fisher distribution. It is recommended to use chi-square for large data set, for example, sample more than 10 lah. So we will be using this one. Okay, so from here we can get to interpret it based on the hash null. The within class covariance matrix are equal, meaning that the grouping that we have, the data in the grouping of bovine, are they having equal covariance? Perbezaan tak jarak dia? And then if yes, it become homoscedasticity. Hash alternative is the within class covariance matrix are different, meaning that they are heteroscedasticity. Kita nak cari this one kan, homo. Macam semalam lah. So as the computed value, this is the computed value of p value here. Lower than significant level 0.05, one should reject the null hypothesis, accept the alternatives hypothesis, meaning that berlaku heteroscedasticity here in the data set. Walau bagaimanapun, as we have conducted the variable transformation, we have treated that one earlier. Remember that we talked, even though we can conduct transformation, it will not simply treat all of this prerequisite requirement that we are shall treat. Sometimes it still cannot be normalized. So we have to accept this data. This is just for the showing why sometimes after conduct transformation we still get heteroscedasticity. Okay, and then this is the box test. This is the one that we discussed, Fisher F asymptotic approximation. The box test is used to test the assumption of equality of four intra-covariance matrix, sama macam atas ni. Two approximation are available based on Fisher distribution and other from chi-square distribution lah. So although it is recommended to use Fisher for small data set, if data set is less than 10, Fisher is actually valid for all sample size. Hence, both Fisher and chi-square are applicable for large data set actually. So for small data set, for example, less than 10, we can use Fisher asymptotic distribution lah. So now we can use any actually. Okay, so the within hash null and hash alternative are similar. We want to check whether the distribution of the data within the group macam tadi, adakah dianya jauh ataupun dekat lah, the variance tu. And then we have the Kullback test. Kullback test is similar to box test, sama juga macam test atas ni. Okay. It is popular since the statistician named as Kullback recommended adopting the chi-square distribution for homoscedasticity test. So this test is similar to the box test lah, ambil je sama macam atas ni. So we have to acknowledge, even though we have conduct transformation, homoscedasticity cannot be treated lah with this data. But we have conduct transformation, that's enough. Okay. And then we will find a Mahalanobis distance, macam bahasa Arab lah pula. So this Mahalanobis distance is used to measure the distance between classes taking account of the covariance structure. So kita ada two groups, satu bovine and one porcine. So we want to check the distance measured between these two groups, berapa jauh and is it significant or not lah. If we assume the intra-class variance matrix are equal, the distance matrix is calculated by using total intra-class covariance matrix, which is symmetric. If we assume the intra-class variance matrix are not equal, the Mahalanobis distance between classes beef and poultry is calculated by using between classes covariance matrix. The distance matrix is therefore matrix lah. Kita nak tahu je dia ada jauh beza ke tak. So this is the distance yang kita dapat lah, 68.8358. Quite jauh jugalah, difference. Okay, and then we will get a generalized squared distance. If the covariance matrix are not assumed to be equal, the table of generalized square distance between the classes is displayed. If generalized distance is also calculated from the Mahalanobis distance daripada atas ni, and use the logarithm of the determine, the covariance matrix together with the logarithm of the prior probabilities is required by the user. So this one, we just want to check the distance. Ada jauh tak beza distance dia macam ni, tengok beef dengan beef zero lah, memang confirm. Tapi beef dengan poultry is far, which is up to 68 unit. So that one will be considered. We have a different grouping. Okay. Now we go to Fisher distance. We talk about Fisher distance. So these covariance matrices are assumed to be equal. The Fisher distance between the classes are displayed. Okay, so sekarang ni kita akan pakai Mahalanobis distance ke Fisher distance. So since we have transformed the data set, we assume the covariance matrix are equal, which is homoscedasticity. Again, macam tadi kan kita dah jumpa dekat atas ni, we conduct a chi-square asymptotic data set transformation before discriminant analysis. However, our data still heteroscedasticity. But as we told previously, by treating it, that will indicate we have tried to make it more to normalize a normal distribution. So in this case, we have to use Fisher distance lah. to cover the homoscedasticity as our assumption lah. Yeah. They are calculated from the Malus-Lewis distance and are used for significant test. Sekejap. Saya punya ni dah habis pula bateri dia. Sekejap ya. Ada ruang dah. Oh, saya dah. Kita tunggu sekejap ya. Nak pasang sekejap. Okay, just continue. Sekejap, kita akan check dekat sini. Okay. Okay, so the p-value 0.05 indicate the poultry and beef classes are significantly different. Ni nak tengok dekat mana? Okay, we can see here. Sinilah, 0.01. The one that we set is 0.05, but the result that we get is 0.001. Which is, this is the distance between beef and poultry, 49, yeah? Because we identify them as homoscedasticity, sebab kita dah, because we have conducted the transformation previously. Now we want to check, is it significantly different? So that's why we go for p-value for Fisher distance. We set the p-value at 0.05, and the good thing is the calculated significant value is 0.001. Yes, that clearly indicate poultry and beef sausage group are really different, betul-betul berbeza. Walaupun pada asalnya macam saya kata, kenapa nak buat multivariate ni? Buat je lah PCR kan, PCR apa dalam bahasa ni? Real time PCR yang selalu orang buat untuk DNA testing tu. Okay. But our multivariate data analysis able to differentiate the grouping of sausage lah. Okay, so this is the indicator. Okay, another indicator that we talk is the Weeks lambda test. Yeah, this is the test used to test the assumption of equality of the mean vectors of two classes. So kita ada beef dan kita ada porcine. So kan macam bila kita plot in the graph, dia akan bagi kita punya vectors, the direction of the grouping. So we want to check whether the mean vectors between these two are equal. So when there are two classes, the test equivalent to Fisher test distribution lah. So that's why we go to Fisher distance. And then when there are more than two classes, the test employ algorithm named as Rao's approximation to follow the Fisher test distribution. So since this is already two classes, so we use the p-value of Fisher distance lah. So this is the result. And then before we make a decision, betul tak dia ni equal direction, equal mean vectors? Go to the hypothesis null, which is the mean vectors of two classes are equal. But the alternative is it's not equal lah, it's different. So as the computed p-value is lower than significant level 0.05, the calculated one is 0.001. We shall reject the null hypothesis. So kita tak nak yang ni, because we have to reject. Now they said at least the mean vector is different from another. So this one confirmkan lagi that the mean vector, the direction tu memang dia betul-betul jauh lah difference. So from this result, the poultry and beef classes are significantly different. So this one supporting our aim lah. Kita memang nak make sure when we get that sample, we able to differentiate, the model able to differentiate whether the sausage is from beef or from poultry. Okay, now we come to the kita panggil apa? Selection or identifying variable mana from the 18 variables, which variable are the significant one. Okay, so apa yang kita boleh buat ialah kita kena susun lah. Sebenarnya this result is not arranged at the first place, but I rearrange the result according to the F statistic value, starting from the highest one to the lowest one. Yeah. So you can see out of that 18, all of the highest F value is for alpha terpinin. But cuba tengok satu-satu. This alpha terpinin, sabinin, alpha 2-gene, aerobic flora, packaging CO2, trimethylbutyryldehyde, sampailah ke packaging oxygen amount. This is the chemical and biological test results. But you can go to the bottom one. Nampak tak yang ni? Rancid up to spoilage, fermented, sulfurous. This is the, kita panggil, apa this is belong to which test? This is the test that belongs to sensory evaluation. So you can see here, those chemical tests and biological tests, sebab kita ada aerobic flora ni, it's enough actually to assist any enforcement or any researchers to identify whether one beef or one poultry sausage belong to their particular grouping. So you can read here, dia kata kat sini, this test aims, sorry typo pula, aims to test the assumption of equality the means between classes. Weeks lambda, univariate lambda is always between 0 to 1. This one lah, lambda ni lah. Ini pun kalau you rearrange, you can see the highest, the significant variable that contribute to differentiating beef and poultry having the lowest lambda. Low lambda indicates high interclass and between class variation, hence a significant between in classes in means between poultry and beef classes lah. High lambda, kalau lambda yang tinggi, contohnya dekat bawah ni, for example spoilage, indicates low interclass between class variation, meaning that this all the bottom variables, they have low significant contribution, low contribution to differentiate between beef and poultry punya sausage. So this also can become one of indicator lah. Okay, lambda and F value are inversely proportional. Low lambda will get high F statistic value lah. F value ni F statistics. So in your discussion, you can choose to discuss on lambda according to low to highest value, or you want to choose according to the ranking of F statistic. So p-value that we have set 0.05 indicates significant variable that could successfully discriminate poultry and beef. So that's why kita rearrange the p-value together to find which of that p-value is lower than 0.05. So you can see, the one that I have highlighted or changed into red color is the p-value of that particular variable which is lower than 0.05. So this indicate dia akan support lah sampai sini. So that's why if we check starting from pH, packaging, O2, resin DT, until to spoilage, these one are not significantly contribute to differentiate or to discriminate the poultry and beef sausage. So based on this result, significant variable that discriminate the poultry and beef classes are alpha terpinin until to alpha pinin. Sensory evaluations do not play role to discriminate the poultry and beef classes. Actually, it's not play role. It play roles, but they play roles, but they are not really strong contributor lah, strong role to discriminate or to differentiate the poultry and beef classes. So you may redo the DA by selecting the significant variables only. Okay, kejap lagi kita buat. We choose only these variables and then kita try to do another discriminant analysis. What we can get later, we can discuss lah. Tunggu saya habis ni dulu, kejap lagi kita sambung balik. Okay, so there is a part of the result from discriminant. They say about this one. Pillai trace. So this test is used to test the assumption of equality of the mean vectors of the various classes. It is less used than Weeks lambda test and also use the Fisher distribution for calculating the p-value. So you see here, kita ada juga Pillai state trace ni. We also have this Weeks lambda test. So dua-dua, both of these two tests are producing similar results lah. So you can choose mana-mana saja. Okay, so you can see, but this Pillai test is used less than Weeks lambda test. And sometimes when people conduct research, they found a new algorithm. So these people create a new algorithm for the similar test actually. But they put their name lah for that test. Mungkin in the future kalau ada rezeki, mungkin Suryati boleh buat your own algorithm. So boleh tak Suryati's trace for example. Atau macam hari ni Sister Alifa's trace contohnya lah. So but what I'm going to say that sometimes similar tests is developed using different algorithms. So different people produce different algorithm and then they put their name lah dekat situ. Okay. So you can see the similar interpretation lah. And then we also have for telling lowly trace. Sama juga macam test Weeks lambda tadi. Similar. But the result is similar lah. Roy's greatest root, this test is used to test the assumption of equality. Ni pun sama juga. So ada banyak kan, kita nampak Roy's greatest root lah, kita ada Hotelling lowly trace lah, Pillai trace. The good thing with SL-STAT, they will calculate according to their individual algorithm, and then some participant or researcher, they will refer to their previous studies. They will try to follow through. Perhaps they want to use Hotelling lowly, perhaps they want to use this Roy's greatest root test. But when you want to choose one particular test, you have to have an valid reason kenapa nak pakai. Ada lagi? Okay, another one, we go to eigenvalues. So this table shows the eigenvalues associated with various factors together with the corresponding discrimination percentage and cumulative percentage lah. So together macam semalam, eigenvalues kita ada. For cluster analysis, we have according to numbers of variable. Unfortunately for this one, this eigenvalue is for the grouping lah. So the table shows the number of discriminating factor is F1. Maksudnya dengan satu discriminating factor saja, or macam if we compare to PCA, we call it principal component. Also we call it F ataupun PC. But for discriminant analysis, they will directly choose how many factors that able to differentiate beef and poultry. Sepatutnya dalam if we compare to PCA, number of F will be based on number of variables. So we have 18 variables, should be they will PCA will create 18 variables, 18 F kat sini. But the good thing with discriminant analysis, dia terus pilih, they will directly choose which factor that able to discriminate. So they say this model say enough with one factor, we still can differentiate bovine and porcine lah. And then we also have a script plot. Okay, script plot is the plotting about the cumulative variability lah yang ni. This plot. Kalau you click sini, you boleh nampak lah. Eigenvalue and script plot dekat sini. Eigenvalue and script plot. So they will use this value for plotting lah. So it's either for you want to use script plot or you want to discuss this table. Mana-mana pun boleh. Okay. And then we have Bartlett test for eigenvalue significancy. This table display for each eigenvalue, the Bartlett statistic and the corresponding p-value which computed using an asymptotic chi-square approximation. So the Bartlett test allow the test and hash null. Ni sama macam cluster PCA yesterday. Similar with the PCA. The Bartlett test allow to test the hash null that all the eigenvalues are equal to 0. Since the p-value calculated yang ni This one that we have. Yang kita dapat is less than 0.05, we reject the hash null, hence the eigenvalue is more than 0 lah. That's why kita dapat value ni. Okay. Similar to eigenvalue to PCA, higher eigenvalue indicates the discriminating factor insignificant, and with one factor the poultry and beef could be discriminated. Okay, cukuplah dengan satu factor pun this model able to differentiate ataupun membezakan sausage tu daripada porcine ataupun daripada beef. Okay. Now we also have eigenvectors. So these eigenvectors is the similar to PCA. Yesterday punya topik lah, PCA explanation of eigenvectors. Eigenvectors is the direction of the eigenvalue. So cukuplah dengan satu saja factors kita dapat differentiate. Okay. And then there are also results stating about variables and factors correlation. So this table shows the correlation of the variables to the discriminating factor. The correlation is value is between 0 to 1. Inilah. High correlation value correspond to high correlation of variable to discriminating factors. F1 they're able to discriminate poultry and beef classes. So yang ni I have rearranged starting from the highest to the lowest lowest correlation value lah. So you can see alpha terpenin ni is the strongest one. Okay. Positive correlation, dalam ni dia ada negatif dengan positif kan. Okay. Positive correlation indicate a positive positive sign indicate a positive correlation. Negative sign indicate negative correlation. So indicate here pH reading, for example, and alpha finin, they are negatively correlated because they have negative sign. But pH reading and packaging oxygen amount are positively correlated because they have similar sign. So that's the similar macam kita punya PCA reading semalam lah. So from this result, which variable are strong correlated with discriminating factors? Could we associate this correlation with the result of unidimensional test of equality of means of the classes? Yes, boleh sebenarnya. So sama sajalah. Okay, so this one, plot this, we call it variable plot. So the variable plot shows the variable over factor correlations. Variable against the factor that we have lah. So since one factor is enough, so you can see one factor is enough. Only one factor already contributed 100%. All the data, 100% of the data can differentiate the bovine. So that's why F2 is 0. So that's why the plotting is pada dia punya axis lah. Because F2 doesn't give any we call that one contribution. So the further the variable to the right or left side of the F1, the stronger correlation is. So you can see lah alpha finin dekat sini apa semua. So lagi jauh, the further it is from this F1, the stronger it is. So for example, alpha terfinin is the strongest correlation, while spoilage is the weakest correlation against the F1. Ini boleh zoom lah. Kita zoom. So tengok yang hujung ni, alpha philandria, sini, sorry. Sebab dia dekat dengan 0. Paling jauh yang ni. Ni apa yang jauh ni? Is it this one? Ni pH reading. Okay. Okay, so that one habis. Confirm about zoning, and then we have canonical correlations. So canonical correlation is the measurement of a discriminant power of the factors. So correlation near to 1 indicate the strongest discriminating power to differentiate the poultry and beef sausage. So you can see the highest one should be 1, but we get is 0.9. Baguslah kita punya discriminant analysis model ni. And then there is also result about canonical discriminant functions coefficients. These coefficients can be used to calculate the coordinate of an observation in discriminant vector space from its coordinate in the initial variable space. This is just for plotting saja. Ni pun sama. Plotting of the variables. So functions of this centroid between the group, what is the mean point to show the centroid of the poultry and beef classes lah. Okay. This one is classification function. This classification function generate individual value of variable for each class. These values are used to create observation plot. Okay. Again, kalau tuan-tuan tengok, tuan-tuan dapat melihat, this is for plotting purposes lah. Okay. Now we move to the last, it's not the last lah, one of the end, the one that we are looking for. Okay. So prior and posterior classification. Okay. So we have C. C is poultry, and then our discriminant model prediction dekat sini dalam kolom ni. So we prepare a poultry, so the model predict poultry. So you tengok semua maintain, still maintain, and then we prepare beef sausage, the prediction also say it's beef. So from here they make a compilation into this table lah nanti, and then this is also centroid. So you can see this one. This is a poultry group, and then this is beef group. Why it all falls onto the same line of F1? Because only F1 contribute to the discrimination. F2 tak contribute langsung. So that's why we don't see any taburan lah. That's why all the sausage sample falls onto the line of F1. On the axis lah. So this is the simplified grouping. So confirm our poultry and beef sausage are properly distinct location lah. So from here, this table ni, from this table yang ni of prior and posterior classification, we can make a compilation into this table. Table tu dekat bawah ni lah. So we have beef sausage, number of them are 32, and our model able to predict all those 32 beef sausage are beef. So it is correct. And then we prepared 38 poultry sausage, and the model able to identify all 38 poultry sausage are poultry sauces. So 100% correlation. Classification. So from there we can make an average. So total is 100% lah. So this matrix evaluate the correct classification of the sausage to the poultry or beef classes. Training sample is the dataset used to establish the discriminating model. Once the total percentage correct achieve 100%, the discriminating model has been established. Okay. So orang akan tanya, so macam mana kalau, what if our confusion matrix ni, they cannot achieve 100%. That indicate what? The training dataset that we have is having problem here. Perhaps we need to remove the one of the training dataset which is falsely classified, because this is training dataset. So training dataset shall be correctly become a database that able to differentiate the classes. Kalau if the training dataset is also having some faulty, so you have to identify which sample are wrong. Perhaps you have different labeling or different analysis. So you have to remove lah the sample and then redo the discriminant analysis until you get 100% correlation. So when you get the data set with 100% correlation, training data set with 100% correlation, keep it as the database. Yang sebab tu the explanation here is once the total percentage of correct classification get 100%, the discriminant model has been established correctly. Okay, kalau tak you kena ubah lah. Yeah. And then you will also see a ROC curve. So ROC curve means receiver operating characteristic. This plotting only appear if you want to differentiate two samples only or two classes only. Kalau tak ada, if more, the ROC curve will not be appeared. Perhaps this is the previous developer of this multivariate data analysis. They want to differentiate two groups, so that's why they create this ROC curve as a supporting event lah. Okay, so from this ROC we could compare the performance between the discriminating models using ROC. Okay, so kalau you have different discriminant analysis model, you can compare between ROC value lah. So you can see ROC will be displayed when only two classes are present in discriminating model. Again, saya ulang benda yang sama. Kalau your sample, your classes is more than two, ROC will not be appeared. Okay. Sensitivity means the proportion of well classified positive. This one. Yeah. Positive event. Maksudnya if we prepare beef, we get beef. Specificity means the proportion of well-classified negative event. So maksudnya if we prepare beef, we get porcine, or we get poultry, that one will become a negative event. AUC means area under curve. Sini AUC ataupun dekat sini lah. This one, area under curve. So we will use this curve, which is a synthetic index calculation for ROC values. Yeah. The AUC correspond to the probability such that positive event has a higher probability given than the given by the model than the negative event. Maksudnya you get more correct classification lah. Yeah. The classification of model performance as below. Okay, so based on this AUC, any AUC value more than 0.7 is a good discriminating model. Any 0.8 until between 0.8 and 0.9, we classify as a well discriminating model. Yeah. AUC more than 0.9, which we acknowledge is as excellent discriminating model. AUC which is equal to 1 indicate an ideal discriminating model. So you tengok AUC here, AUC here, what is the value? 1. So is it ideal? Perhaps yes, but there is also dalam dunia takkan ada yang ideal lah. Yeah? But we can say it's ideal theoretically, but we will go to next discussion sekejap. Ada satu ayat lain, okay? So macam mana nak explain about this one? Is it really ideal? Okay. So go to cross validation to check whether the ideal AUC are really ideal. Okay, macam mana? Dia akan buat cross validation lah. Yeah. So the discriminating analysis will create a cross validation test. Macam mana dia buat? Yeah. Since AUC from the ROC curve may establish two optimistically discriminating model. Macam saya cakap dalam dunia tak akan ada, there is no ideal thing. Yeah? We may need to verify the discriminating model ability on individual poultry and beef sausages. So to validate the discriminating model, we carry out cross-validation activity. So that's why you will see any discriminant analysis under Excel stat. They will create a cross validation, to support your results lah. This cross validation involves removing an individual sausage from the training data set, and this discrimination is done. Repeat this activity for each sausage, then the confusion metric for the cross validation result is created lah. So dia akan buat satu-satu lah, they remove one by one. They want to check whether is it correct poultry is poultry, and then they remove the model will remove this rerun, and then they remove another sample, and then they will check the whole system. Is it having poultry and predicted by poultry again? Yeah. They buat satu-satu until to all 70 sausage. So you can see from that they will make a confusion matrix based on this cross validation. Dekat sini baru nampak betul ke you punya ideal. So nampaknya macam tidak, sebab we have beef that we prepared 32. And good thing is the model able to correctly classify 32 sausage is beef. However, for poultry, out of 38, only 37 is poultry and one is suspected as a beef. So the correct classification has been changed into 97.37. So kita punya average is 98.57. So this discriminating model, what happened to them? Is it acceptable? Still acceptable, but it is recommended. Ikut yang ni, dia cakap kat sini. If, sorry. Dia cakap dekat sini, still acceptable because we already set up the p-value is 0.05, which is we allow 5% error, which is acceptable. Correct classification is 95%, so boleh diterima. Some people, after they conduct a confusion matrix, the correct classification falls below 100%, they will identify which is the one that having problem. Ni sample ni having problem ni. CO2 73A3, this sample should be poultry. However, the model identified as a beef, meaning that the location of CO2 73A3 ni perhaps is too near between the beef and poultry group. That's why it can fall to the opposite group lah. So what we can do, we go back to variable transformation ni, find mana which of the poultry sample which is wrongly classified, and then we can remove that and then rerun again the discriminant analysis lah. Okay, so up to that level, actually we need to conduct another test which is using discriminant analysis. I think I allow for open and Q&A first, and then we have some 15-minute rest first, and then we continue with the DA with significant variables only. Okay, Sister Alifah, go back to you.
Okay, Dr. Shirwan, we got two questions. First from Sister Nurul Fahana. Assalamualaikum, Doctor. It is fine if the percentage of principal component is low, even though we already use PC1 and PC2.
Again, apa yang low? Percentage?
If the percentage of principal component is low, even though we already use PC1 and PC2.
Yes, it is still possible. Okay, macam ni we talked about PC1 versus PC2 yesterday. The principal component analysis PCA result that we get is 75%, meaning that the whole data that we have, only 75% are meaningful in our study. It's still acceptable, provided that you compare to previous study. Kalau those previous study they can go higher than that, that will become a challenge to you. However, in certain case and most of case, there is nobody being introducing or using multivariate data analysis or PCA for your study. So you are the first one. So it's acceptable at any numbers of percentage actually. So you can become the trendsetter lah. The next researcher that using their own data who referring to your paper will become a challenging to them lah. If you set high percentage in PCA, they will become challenging to them. In certain case, for example, last time after we conduct multivariate data analysis in food studies 1.0, there is one participant coming back to us, and then when we check, they have 60% PCA, PC1 versus PC2, only 60%, but she's the one that doing the first one doing PCA in seaweed samples, and different variables as well. The first one, as far as I know lah. So because of that, it's still acceptable because you are the trendsetter. So this is my recommendation lah. So jangan risau, don't feel worried, unless you have to be careful if other people is doing multivariate data analysis with similar metrics, with similar variable, and then that become a challenge to you because you have to make a higher percentage or similar or comparable percentage lah to them. Okay, ada soalan lagi?
Okay, next question is from Sister Izzat.
Yes.
From doctor, what is the difference between F, which is observed value, and F, which is critical value? Which one should we refer to?
Again, what if F?
What is the difference between observed value and critical value? Which one should we refer to?
Observe and critical value.
F for observed value and the F for the critical value.
Oh, this one under okay. Critical value. Okay, observed value is the calculated one. Critical value, the value that we remember in our zaman sekolah kan, kita we have that kind of buku table, tapi itulah I dah tua, so mungkin I pakai buku, I'm using that kind of book previously, so they have that critical value in that table, so that is the critical value that being set statistically, we are referring to that table. Yeah. Observed value is the calculated one by the model itself or by the test itself. Like this one related to hash null and hash alternative lah. So observe is the calculated one. Critical value is the one that we are referring against to. Yeah. So the one that being set up in that table from the statistical punya calculation lah. Yeah. So I think that I hope that's answering. Kalau tak answering, kita boleh discuss more lah on that. Okay.
So far that's all.
Okay. Okay, so since we have reached to the first DA, kejap lagi kita akan buat another discriminant analysis with significant variables only. So I think we can start at 11:15 afterward. I think more kita akan rehat lah, maybe 20 minutes. So see you again. Kita akan continue later about the next discriminant analysis. Okay, thank you again. See you later. Assalamualaikum.
Okay, just want to add, Dr. Shivan.
Mm-hmm.
I will share a list for participant for certificate. Kindly check your name and then tick either the name is okay or not. If not, you can edit from the list. Okay, that's all.
Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh. Kita sambung
Waalaikumsalam.
sekejap. Sekejap ya, saya nak setting sikit. Mikrofon. Kita sambung
Boleh?
Okay. Kalau tak dengar cakap sebab saya takut saya punya mikrofon ni ada problem. Okay, so sekarang now we want to try how about if we select only variables with p-value less than 0.05 from the transform datasheet. Okay, so sekarang kejap. Okay. So this one, kalau tuan-tuan tengok, lihat sekarang, I have shared another set of similar set of variable transform variables, but this time I only choose significant variables only. Okay, this one from where? Okay, this one from unidimensional punya table. Kejap. Sekejap ya. Okay. Stop sharing. Okay. Sekejap saya buka balik. Enable editing. Okay. Okay. Kenapa dia tak boleh buka ni? Sekejap ya. Discriminant analysis. Okay, tak apalah. Okay. Okay, so I just proceed lah yang ni. I tak sure kenapa dia susah nak buka pula apa tu. This from discriminant analysis punya tab ni. Okay, previously we found the unidimensional punya the unidimensional results. So from we identify, kan kita cakap tadi, we identify all those chemical testings, including biological testing and packaging carbon dioxide ni are the significant one. So we choose only these variables. We create the similar column which is called class for poultry and also beef. Okay. Now we want to rerun with the discriminant analysis again. Okay. So let us start. We will conduct a new cluster discriminant analysis using the significant variable only lah. Okay. So how? Again, go to discriminant analysis. Oh, tak kena tak keluar Okay.
Tak keluar.
Okay, keluar tak?
Okay, keluar.
Okay. So, again I repeat. So this variable are the variable that the chemical analysis and biological analysis which actually contribute or the significant one from the unidimensional table. Okay, so we choose only this variable and then we create a new column which is class and then we label them according to sample that we have. This one we only choose the significant variables only from discriminant analysis in the first discriminant analysis. Kita nak buat yang barulah. So we go for rerunning the discriminant analysis using this data. Okay, so again, go to analyzing data, choose discriminant analysis, go to Y dependent variables, this one, choose title for the class title and then drag down to the last row. Then for X explanatory variables, again, choose quantitative box. So go to the first sample name, which is packaging CO2, drag to alpha terpinene and drag down to the last row. Okay, make sure you choose sheet and then variables label and observation label shall be ticked the box. And then for observation labels, choose your samples name starting from sample title, drag down to the last row, the last sample of beef sausage. Okay, dah sudah. And then for options again ni sama saja. For tolerance, this is the tolerance that we identify that we set 0.001. This one for the one we are going to identify the multicollinearity lah. This is a similar thing lah. Okay. Significance level 5%, which because we want to have a p less than 0.05. For validation, let it be. For prediction, also let it be. And then for missing data, choose remove the observations. For output, tick all boxes. And then for charts, again, tick all boxes and you have to make sure for number of observation, choose 10,000 lah. You can go higher than that. Okay. And then you click OK. So again, you will get a selection name of Y. Qualitative data is 70 rows because you have 70 samples, but only one column because one group of class. And then for X is for your quantitative sample, which is we have 9 variables only. So out of 18, 9 are the most significant one. So rows is 70 because you have 70 samples. So observation level as well, 70 samples with one column because you have one column here, this one. So only one column. So you click continue. Okay. So you will get DA3 lah. So for this explanation, I have prepared for you with the title name of sheet DA1. So buka yang ni. So mari kita tengok apa yang berlaku. Okay. So actually, we don't want to repeat the similar discussion. Now we want to see the what is the updated information that we can get daripada sinilah. Okay, the updated information that we can get from here is this one. Sekejap. Okay, so with 9 variables, 32 beef is correctly classified as beef. Okay, ni sama. So we get 100% correct classification. Poultry 38, we get 38. Yes, correct. So total 100%. Okay. Now we go to this cross validation sebab we still get AUC as 1. Idealnya kan. So now let's go to check at the bottom what do we get. Okay, so now we carry out cross validation. We want to check betul ke this is ideal, AUC equal to 1. Is it correct? Betul ke ideal ni? Okay, so we go for cross validation. Drag down to the bottom. Now kita nampak tak difference dia? Yeah. We have 32%, 32 beef, we get 32 beef. It's 100% correct. Poultry with 38 poultry, it is correct 100%. And then total is 100%. If we compare to the result from 18 variables, from the result of 18 variables in the previous DA, the first DA, we'll get 60 berapa tadi 62 98 something percent cross confusion matrix lah. But now we can get up to, with 9 variables only, we get 100% correct. So that will indicate apa? What will indicate? So in order for us to develop a discriminating model which is ideal or perfect or better, we carry out first the DA using the whole variable that we have, which is 18, and from there we select the significant one only, and then rerun the significant variable to find the correct classification. So now we have achieved training data set is 100% correlation. This one, yang ni kita nak, this one. Now, after we make correct cross validation, we also get 100% what we call that one, correct classification lah. Yeah. So from here, kita akan cakap, we will say that we have established a good discriminating model. So this is what we are looking for. So in order for you, if you are dealing with any classification of food samples or halal analysis, for example, you want to differentiate between bovine, porcine, fish gelatin, before we develop, kita claim we have the best discriminant model, we have to follow through this method first. Take all those variables, run with DA, and from the unidimensional table, select the most significant one, and then check the cross validation. If we get cross validation 100%, training data set also 100%, that will indicate your discriminating model is the best discriminating model for now. And this data shall be kept as your database. Macam ni lah. So we have reached to the end of application of discriminant analysis for today's session. Okay, so sampai situ ada soalan tak? You have any question before we move to the last session?
So far no, Dr. Syuan.
Okay. If no, ya saya kena ni kejap. Okay, so kalau tak ada soalan, we move to the next session, which is yang ni nampak? Okay. So now we have carried out 2 times of DA. The first one is to just evaluate and then identify the significant variable that able to discriminate classes or groups by selecting the most significant one based on the F statistic and P value we rerun again the DA. This one, if you confirm, we can get 100% classification in training and cross-validation data set, cross-validation test that indicate you have established a model. And uh, uh, variables, the non-variable that you have, and the sample itself shall be kept as your database lah. Yeah. So up to that level, we have complete the last part of the third part of our workshop, which is a discriminant analysis. Now we are moving to the next part, which is multiple linear regression in food studies. Okay, so the question is, what is the function of multiple linear regression? Okay, the first thing that this title comes to our mind is we have the word regression. When we talk about regression, it should be quantitative. Eh? If we compare with discriminant analysis, they will assist us on giving the group of our sample. This belong to porcine, this belong to beef sausage, this sample belong to poultry sausage, qualitative. But now we want to know how much the percentage of contaminant, for example, in the sample. So we will identify the result in a quantitative form. But this time multiple linear regression. So this is the another option or another test can be done if you want to identify how much contaminant in our sample. Okay. So we start with the introduction. So multiple linear regression, sometimes if you go to environmental study, they will say MLR, MLR in food studies. Okay, so in environment, they will call MLR in environmental study lah. Yeah. So this MLR can be originated from different regression. Yeah. So regression analysis, not only MLR, there are lots of regression analysis. One of it is partial least square regression, PLSR. Salah satu lah ya. Partial least square discriminant analysis. And then principal component regression. Oh, sekejap I betulkan balik. This one, you have to delete. Partial least square discriminant analysis. This is actually not belong to linear regression. So we have to remove. This is false to discriminant analysis. This one, I'm sorry, I have to remove this one. So beside of MLR, we also can have partial least square regression, PLSR. We also can have principal component regression, PCR, and then orthogonal partial least square discriminant analysis. This one as well, sorry, ni pun kena delete. Kita tak nak. This is belong to discriminant analysis. Discriminant mean discriminant. So dia kena keluar lah. And the last one is MLR lah, multiple linear regression. So any word that having regression, they are belong to regression group. However, they have different algorithm to make the regression lah. So when we want to choose which one is the best, we need to carry out regression using different type of regression activity, and then we compare them. From there from there we can decide which regression analysis is the best for our matrix, sample matrix lah. So these regression analysis are employed to develop a regression model for the predictive value and quantitatively in the unknown samples. So maksudnya, we can identify how much contaminations or how much one particular thing in the unknown samples. So for any regression analysis, quantitative value of dependent variables are present. So again lah, if we compare with our results here, with our data set, for example, previously, we have bovine and porcine, but the data is quantitative kan, so that one can be used for as a variable, but the data itself having poultry and beef sausage information, that one is not quantitative, that one is qualitative. This one, we want to have a dependent variable which is quantitative. Lepas ni kita tengok. We will see how the data set looks like. Okay. This step also needs training and testing data set. This one macam similar like discriminant analysis. We still need training and testing data set that include the significant variables determined in PCA and confirmed by CA and DA lah, but it's not compulsory. Not compulsory pun. You can just do it directly before conducting PCA and CA or even DA lah, no problem. Boleh buat sahaja. But it is good if you have a flow of research, we can start with PCA, confirm with CA, and then you can go directly to DA or even go to directly to DLSR lah. Atau sorry, MLR, multiple linear regression. The training data set consists of grouping of sample sources with unknown values, while the testing data set is comprised of the unknown sample. So training data set, we have a sample source with a known values. Known values mean how much the contaminant that we prepared or we have in the samples. And then testing data set is comprised of unknown sample because we want to predict how much the contaminant. So we will have a testing data set. Okay. These data sets must also fulfill the KMO more than 0.5 requirement prior to regression analysis. Okay. So this one samalah. Any multivariate data analysis, it is recommended that you have a KMO more than 0.5 to say that or to confirm that our data are eligible for multivariate data analysis, including multiple linear regression. Okay. So for us to review or to check whether the regression is acceptable or not, we need to review the multiple linear regression result via the goodness of fit statistics lah. So dalam this statistic, there are a few parameters that we can compare. The first one is determination coefficient or R square. Yang ni samalah macam kita buat regression biasa. That's why the title is regression. So we have R square, like we are making a calibration curve, we can get R square, okay? So we can refer to this R square. We also can compare mean square error, MSE, and root mean square error for each regression. For R square, the closest R square to 1 is considered good or acceptable and better, okay? And lowest IMSE and RMSE is also considered good regression model lah, multiple linear regression model. So R square should be high, MSE and RMSE should be lower. Because this characteristic indicate that selected model has the lowest probability of incorrect predictive values. Kenapa ada 1% ni? 1% ni sebab kita set 0.01. So that's why we call it 1%. If we choose 5%, 0.05 lah. The predicted and actual values mean shall be evaluated to assist the selection of the best regression model. The p-value more than 0.01 of the Z-test or t-test denote that the null hypothesis is accepted and the predicted and actual values are not significantly different. Okay, another step to ensure or to check whether the prediction done by multiple linear regression is okay or not by having a Z-test or t-test. So Z-test and t-test is used to compare the predicted value, the one that we have prepared, and the actual values predicted by the MLR. And then we want to check whether they are significantly different using this Z-test. So this is the how we can use to compare whether prediction is correct or not. The discriminant, the DA previously kita compare dengan correct classification. But this one for MLR, we can compare using the this one lah, R square, MSE, RMSE dan juga Z-test. Okay, this is an example yang I cakap tadi. We go back to this nota, ayat dekat sini. The sentence say here, it should be quantitative value of dependent variable, which is mean this one. This is dependent variable. This is the dependent variable. This one. So you can see the class, okay, Kalau if we go for discriminant analysis, we can use this one, palm oil, lard and palm oil as a grouping. This is for the A. But now, we want to know how much decontamination. So kita akan pakai, we will have a quantitative value. So you can see here, 0% of lard, 25% of lard, 50% of lard, 75% of lard. You can see here. So this is, we call it training data set, and this is the quantitative dependent variables. This is your variables lah. Again, this is under TAG, triacylglycerol as an example. These dependent variables, increasing trend as a calibrant value. So you rearrange your sample starting from the lowest LUT, for example here, your contaminant, up to the high concentration of contaminant. So you can see here 75% of contaminant lah. So if we are talking about what we call that one, polyaromatic hydrocarbon as in food, for example, that's become contaminant. Ataupun we want to have some particular bacteria level, for example lah. Okay, so you can rearrange the amount of contamination starting from the lowest to the high. Okay, so this has become a calibrant value. Okay, so this is an example how the data set, the training data set looks like. Okay, now after we carry out multiple linear regression using SLStat, you will get this goodness of fit statistic. Okay, so which one we shall refer? You shall refer to R square 0.9971 here. They will say model with higher R square is better. And then we also can refer to MSE, RMSE. Model with lower MSE and RMSE is better. Okay, actually yang lain-lain ni, MAPE lah, DW lah sampai Q2 ni also can be used as a reference. But what I want to emphasize is most of papers right now, currently, they are focusing on this three. You also can refer or compare with all the rest of these parameters lah, or characteristic. No problem. But if we want, if you found any paper having these results and you want to make comparison, you can choose all these three, and this is the most popular one. Model with the lower MSE and RMSE is better. So kita nak high R square and low MSE and RMSE. Okay. Then you can also get a result of analysis of variance given by the MLR. Okay, so you can see dia kata kat sini, given the R square is 100%, the variability of the dependent variable cluster is explained by the 13 explanatory variables. So you can see here lah. The one that we calculated is 0.001, but the one that we set is 0.05. Boleh tengok kat sini. That indicate the variables, the 13 variable that we have are explained by the become 13 explanatory variables. This PR value, which is probability value less than 0.05 that we said indicate the variables contribution are significant. Okay, so get this information, R square, RMSE and RMSE, but you want to find whether all the variable that you have really explain your model. You can check on the probability value. Then people will be asking, since we have MLR, multiple linear regression, dia adalah regression, meaning that they have a formula macam like we make a calibration curve. Kalau calibration curve, we use Y equal to MX plus C. Okay? So similar to linear regression, if we have a multiple linear regression, they will also produce a model equation. Macam equation ni lah. So the equation will be here. Cluster percentage, meaning that berapa banyak contaminant. This is the formula lah. This is your variable. Tak nampak. This is your variable. This is your second variable, third variable, and so on and so forth. Maksud dia, if you have more variables there, the equation will be longer. Okay, so this is how the MLR results looks like. Okay, now kita nak buat apa tadi? Okay. This analysis of variance only to tell us whether those variables that we selected are really explaining the model. Now, what are those 18 among of the 13? What are the one individual variable that really significant? Okay, that's why we have one table. We call it standardized coefficient table. Okay, so from here you can see variable with higher absolute value of a coefficient has more important the weight to the MLR model, meaning that they are more significant value lah. The ranking variable weight is C18 3, C20 14, 18 2, 1, C18 0 and 16 0. So according to the higher and lower. Okay, again, this one, even though they have negative value, we have to make it absolute lah. So kita arrange according to absolute value. Okay. Oh, sepatutnya dia dekat atas ni, terbalik ni, sorry. Okay. And then variable with probability PR more than T, this one, which is less than 0.05 indicates significant variables. We set 0.05 kan. Okay, so if we get 0.01 here, that indicates C183 is the most significant one. Influential lah. So instead of you focus on this one, you just focus on this one pun boleh, acceptable. Okay, so if we compare, the most influential is C183. The less influential or significant is C16 0 lah according to probability. So boleh pilih this one atau this one. So for me, I will prefer this one lah because we already set up 0.05 as our guideline. Okay. So now we move to the next slide, which is we are talking about testing data set. Okay. The previous data set that I show to all of you is the training data set, which is this is become our database. Okay. Now we want to check, are they able to predict numbers of contaminant? For that purpose, we need to create a testing data set. Okay. So inilah testing data set ya. Okay. This one is we already know the percentage contaminant. We want to check nanti how many predicted done by the percentage of contaminant by the model itself. So nanti dia akan createkan satu result. So we need to compare between the one that we prepared and the one that being predicted. Okay. So when we carry out the prediction, so this is one of the table result yang already compiled. Okay. The actual one that we prepare is 0, 25%, 50%, 75% and 100%. This is the one. Okay. Yeah, yang ni, this one. Yeah. This column. Yang ni the one that we have prepared. Yang ni lah. 25, 50, 75 and 100%. Now they produce a predicted value by the discriminant by the multiple linear regression model. So they get, okay, for example, we prepared 0 LUT. We get negative 4.99. So 0 lah. Okay. We prepare 25% of LUT. We get 21.50%. We prepare 50% of LUT. We get 45.42 prediction. Yeah, we prepare 75% of LUT, we get 72% of prediction, and we prepare 100% of LUT dalam in the fish feed, we get 99.18%. Yeah. So dekat sini, from here we can compare between actual LUT prepared and then predicted value using a Z-test. Okay, so when we try to compare the Z-test, you can use Z-test or T-test. Mana-mana pun boleh actually. But T-test is if you have more samples, which is we assume it as the T-test we assume it as kita panggil apa yang tu? Samples, and then if you have more samples, we can identify that as Z-test. Okay. So we compute the Z-test and T-test between the predicted and actual values at 0.05 significant level. And then we try to evaluate using the hash null and hash alternative lah. So hash null state that the means between predicted and actual values between this one, yeah, the mean are the same. Maksud dia there is no differences. Maksud dia this is the one that we are looking for. We want them to be same. We prepare zero, it should get zero lah. And it should be not significantly different. Macam tu lah. But this Z test also offer hash alternative ataupun hypothesis alternative, which mean the means between actual prepared sample and the predicted sample are different. So bila dia different, which mean our model to fail lah to predict correctly, kan? Okay. So we calculate the Z test and we find the try to check the p value produced by the Z test. If the p value of the Z test have value more than 0.05, that indicate we need to accept the hash null. It also indicate that the predicted value and actual values are not significantly different, which prove the MLR model are useful predictive tool. So you can predict your contamination using this MLR. Okay, so up to that slide, any questions so far? Rasa pening tak this one? I think dia tak pening, but the application will be different lah. Sekejap ya. So if there is no question, let's go to the next part, which is we want to have a hands-on on multiple linear regression ataupun MLR. So before we start with this one, okay, this one I provide a new data set, okay, fatty acid composition mixed with olive oil mixtures lah. Generally, if now people are using olive oil, sometimes people make a mislabeling lah. They want to have a cheaper, they want to sell olive oil with a higher price, but they mix with palm oil. It's like penipuan lah, some fast claiming, and then we call it adulterant lah. So in this case, palm oil become adulterant in olive oil mixtures. We know to produce an olive oil is very expensive. So people add palm oil to olive oil to sell them at higher price, but with a lower olive oil percentage. Okay, so palm and olive oils, multiple linear regression, the data that we show or we give to you provide information on fatty acid composition of mixture palm oil and olive oil, which focusing on authentication of olive oil. We want to make sure that the olive oil is very authentic. It is very tulen lah, pure one. It's not mixed with any other oils. So what we need to do is we need to open file number 7 with title multiple linear regression MLR. And then we need to show the test and testing dataset first. Carry out MLR on testing dataset. Click modeling data and choose linear regression. At output generating all except type 1 and type 3 SS, price and interpretation. And then tick normality test. Okay, mari kita buat dulu. And then afterward, we will carry out another MLR to make a comparison. Okay, I show first where are the files. Okay, there is no other else files that we need to open. It's just the last one, number 7. Multiple linear regression analysis, this one, number 7. Open up this. Click this file. And then click enable. So I share the Excel. Okay. So what we have here, okay. Go to the sheet of transform variables. Okay, again, all the data have been transformed. So tak payah pening kepala, you don't have to become a headache people. Okay, already transformed for you. So we just want to continue with the multiple linear regression. Okay, but I have to show to all of you. You can see for the first data, there is a transformation being carried out. There are uh, three sets of data here. The first one, the first table, which is called as training data set. So you can see we have 0% of palm oil, 25% of palm oil, 50%, 75%, and 100% lah. 100% palm oil, so 100% palm oil only. And then underneath of that training data set, there is a testing data set. In this case, we analyze what we call that one? We prepare a mixture of palm oil and olive oil, which is we already know the concentration. Kita dah tahu pun sebenarnya. We just want to check the ability of the model. Could they predict 0% palm oil here really 0%? Or how much is it? And then we can compare later lah. Okay. And then 25%, is it 25%? And then the last one, the last table, we have prepared an unknown sample. So this is just for the sake of can they predict? Itu sajalah. So we want to know how much the palm oil adulterant predicted by the model itself. Okay. So now, kita tengok yang tu. Let's go to multiple linear regression. So open up your Excel stat. Open up the column. Okay. So go to modeling data. Sebelah pula. Semalam, yesterday, PCA, discriminant and AHC, agglomerative hierarchical clustering is under the analyzing data. But now for multiple linear regression, we go to modeling data. And then you click linear regression. Yes, and then you can get the dialog box. Okay, again, open up your Excel stat, open up the icon, click the icon, and then choose modeling data, click linear regression, and then you will get this dialog box. Okay, so for general, name as y, which is your dependent variables. So remember, it is quantitative. So kalau if you found it state as qualitative, perhaps the one that you open is discriminant analysis. But you can check lah, this one is linear regression. So make sure y dependent variables, click quantitative, click that one. Go to the testing data, training data set, click the title of palm oil adulterant, drag down to the last row of that particular table. 100% saja. Jangan tarik sampai bawah. We go for testing table only. And then for X, which is explanatory variables, tick the quantitative box. Yes, because our data is quantitative. Tick that one and then choose starting from C14.0 title, go up to C18.30, C18.3, and then drag down to the last row of that table. And then for observation labels, again, go to the sample name here, and then drag down to the last sample. Okay. Okay, boleh So again, for Y dependent variables, click the palm oil title, drag down to the last 100% palm oil. And then for X explanatory variables, tick the quantitative box. and then click C14.0, drag to C18.3, drag down to the last sample row, and then make sure you click sheet. And then for variables, labels, and observation labels, please tick those boxes. And then for observation labels, click sample title, drag down to the last sample name. Okay. Up to that level, we complete on setting the data for training. Now go to options. Sekejap ya. Okay. Go to options for models. Okay, you just make sure the confidence interval is 95%. Yeah, 95%. For covariance, let it be, tak payah buat apa-apa. Okay. For validation, let it be as it is. Prediction as well, untick prediction. We don't want any prediction yet. Yeah. And then for missing data, click do not accept missing data. Again, because of what? Because at the first place, we have stated that we have transformed the data and removing any missing data. Okay. And then for output, click all of it, all boxes. Output. And then for contrast, let it be as it is. Test assumption. Okay, sekejap. Test assumption. Okay, please tick normality test. Oh, sekejap. Okay. Test assumption, please tick normality test. But for add output, the general part, okay. Okay, sorry. Tick all except type 1 3SS. Kita tak nak yang ni sebab dia too longer interpretation. We don't want this one. Kita tak nak yang ni. And then contrast and test assumption. Okay. So for test assumption, it should be normality test kena tick lah. You have to tick. Okay. For charts, tick all of it. Okay. So again, option, model, make sure it's 95% confidence level interval. Covariance, let it be. Validation, don't tick anything. Prediction as well, let it be as it is. Missing data, choose do not accept missing data. For output, go to general, tick all kecuali except type 1/3SS, accept press, accept dengan interpretation. So all these three boxes shouldn't be ticked. For contrast, let it be. For test assumption, you have to tick normality test lah, because we already know it's already normal. Okay. And then for chart, tick all of it. And then you can click OK. Okay, so you will get a result as linear regression lah. Okay. So for the purpose of explanation, I will choose linear regression, what do you call it one? Test only, sheet only. Ni nampak. Sekejap. Save. Okay. So, saya share balik the files. Okay. So now, yang ni nampak Okay, nampak? Okay. So let's go about the explanation. Okay. So the first one, we want to check whether our model, MLR model, are good. Okay, so we go for goodness of fit statistic. Buka yang ni. Okay, so from here, you have to evaluate lah. So what you can evaluate, you go to check on R square. So model with higher R square is better. So now we have 0.9989. We know the nearer it is to 1 is the better model lah. Okay. And then we can check MSE and RMSE. So we can get this one, the error is 1.94 and 1.39. Yeah. So the lower mean square errors and root mean squares is better. So generally, if you want to choose or to try other regression technique, we have PLSR, we have lots of regression technique, PCR. So go test, conduct the regression, and then you compare all this method, which one having higher R square, which one having lower MSA, lowest RMSE. So the one with the highest R square and lowest MSE and RMSE, that indicate the best model for your matrix lah. Okay, so this is how we can compare between variables, between regression technique. Okay, now based on our variables, we have how many variables we have? 1, 2, 3, 4, 5, 6, 7. Okay, out of 7 variables, kan dah ada tulis kat situ number 7, nak juga kira. Okay, just want to confirm lah. Okay, out of 7 variables, do these variables really give significant contribution to this model? Macam mana nak tahu? How to check? You have to check on the probability value numbers lah, or value lah. So the probability value that we get is 0.0001, which is indicate lower than 0.05. That will support the claim that all the 7 variables are significant in our MLR model lah. If it is more than 0.05, that indicate the variable is not significantly contribute to develop the model itself. Okay, so this one correct, but now people will be asking, or will be asking, so among all those 7, which one are the best? Okay, so this is the one that we have lah. Okay, go to standardized coefficient, and then rearrange the PR value over this one, starting from lowest to the highest, and then those probability of PR which is lower than 0.005 indicate that are the most significant contributor to the model lah. Okay, all of these 7 variables or parameters are contributing to the MLR, but we want to check which one is the most contributing variable. So in this case, C183 is the significant one lah. The low of probability value, the significant the variables. So it's not say that we need to remove all this C20 up to C16. We don't have to remove them, but we want to check, or we want to find which are according to the ranking, which one are the most significant contributor to the MLR model. Okay. Okay, so this table supported by the table, we call it kita panggil apa? Standardized coefficient table lah. Okay, meaning that tengok dekat sini, those variable having the bar which is further away from the axis, zero axis, from this one, indicate the most significant variable. So in this case, you can see C6183 are the bar that furthest away from the axis 0, followed by C20, C14, C18, C181, C180, and C160. Okay, so that indicate this is C183 is the most significant one lah. Sometimes it is a good option to just paste this figure, this one, to your thesis or your paper to show them the significant variables lah, instead of just using this table. Yeah. So you boleh guna, you can use any way of doing explanation. You can use table, or you can use the more visibility using this kind of diagram lah. Yeah. Okay. Let's see how to explain. Okay, why C16 0 is the least significant. Why? Okay, because most of palm oil or oils, plant oil, having C16 0. So if olive oil also have C16 0, palmitic acid, this is palmitic acid C16 0. Palm oil also, they have high number of C16 0, so we cannot differentiate because both of oil having the similar characteristic or numbers of C16, palmitic acid. So that indicate C16 3 in olive oil or in palm oil will differentiate whether that particular oil that we have having palm oil or having olive oil. Okay, so that indicate 618 is become the kingmaker to differentiate whether it's olive oil or palm oil. Okay, so what else we can see from the result? So I just move. Okay, this one is the prediction, the calibration. Remember that we told you, okay, this is the calibrant, the percent. Why we need to rearrange according to the lowest palm oil adulterant to the highest one, because these are the calibrant. So because of that, we can get the result like this lah. Okay, so the one that we prepared is here. The one that we predict, the one that we prepared here, the one is we predict is sama lah, mana-mana saja. So you can see there are linear linearity trend. So if we plot the R square, we can get the R square 0.9989. Tadi kan the same. So this is the square lah. Okay, what else that we can get from here? Okay, yang ni I tak perlu explain sebab it's not really important part because it's replicate of the result. Okay, sampai sini, up to this level, we have known what are the significant variables. Now, how about we want to train the data set? We want to train the model. We want to we want to test the model, how good it is. Because these results, all of these results that we get is from the testing data set. Kita baru, we just train. This is testing data set. We just test training data set. We just train the model. Now we want to test the model, the capability of it. Okay, so what we do, we run again Excel stat. We run again Excel stat. But this time, what we need to do, okay, again, this one I taruh je lah ini. We do again, y dependent variable is using the training data set. Explanatory is using the similar what we call that one, variables. Click variable label, observation label, similar like the previous MLR. I need to redo this one. Put okay. Now open up the prediction. Open up the prediction tab, and then you tick prediction box. And then on explanatory variables X, quantitative, you have to tick quantitative, quantitative box. Okay, tick there. Go to the testing data set. Okay, this time we want to select the cells underneath of the variable label. Kita tak nak C14 tu, we want the sample itself. And then drag down to the lowest row. Okay. And then for observation labels, again, go to the sample name only, not the sample cell. Sample name, starting sample name, drag down to the lowest or to the last sample in testing data set. Again, testing data set. So again, before we start, click OK. Okay. General, this one is similar step. Click pump oil deterrent until to the lowest concentration. For X, in training data set, go C14 to C18.3, drag down to the lowest sample, to the last sample. Click sheet, click variable labels, click observation labels box as well. And then for this one, choose your sample. Sorry, you have to choose the sample name. Then we go to options, make sure its confidence level is interval is 95%. For validation, let it be. For prediction, now we want to predict, to test, tick the prediction box. For X explanatory variables, tick quantitative box, but this time, go to testing dataset and then you choose the first sample results, not the samples, not the variable label, samples result or the first variables result. Drag down to the last sample results. And then for observation labels, you choose the sample name. We don't want this one. Kita tak nak yang ni. We only want the sample name dekat sini. This one. And then for missing data, do not accept missing data. Output for general, tick all of it except type 1, 3, SS, accept press, accept interpretation, kita tak nak. For contrast, let it be. Test assumption, still stick to the similar one, normality test. And for charts, just tick all of it. Okay. Apa lagi dia nak ni? Okay. Then you can click OK. Okay, so from here you can see from your testing training data set, you have 25 variables. 25 samples. Quantitative is 25 as well. With 7 column, which is 7 variables. Observation level is 25 with 1 column. Prediction is for your testing data set. We want to check whether the model MLR that we built in the training dataset able to predict our testing dataset. And then you can click continue. Okay. So you will get the result of linear regression 2 lah dekat sini. We will get the results of the second discriminant analysis. Okay. So kalau tuan-tuan tengok, okay. This is the one that we are looking for lah. Okay. If we have the transform variables here, yang ni, can we have already this one, actual palm oil deterrent 0, 0, 0, 25, 50, 20, 75 and 100. We want to check how much prediction that they can get. Is it correct or not? So Allahu Akbar, kenapalah dia ni? Dia hang sikit. Okay, just biar macam tu je. Okay, so I'm sorry, saya tak sure why I cannot share. No, my Excel having problem. Okay, so thank you Nomi for sharing. So you can see here, on the right side, the one that with yellow, yang paling hujung sekali, we prepare 0, 0, 0, 25%, 25%, 25%, 50, 50, 50, 75, 75, 75, and 100. Okay, now we go to the column, which is already labeled as yellow, yeah, predicted palm oil adulterant. Yeah. So from there, you can see you get 0, prepared, you get 0 and -2, -3. So indicate 0 lah. Yeah. You prepare 25% of palm oil, you get 24.7 and 24.5 and 24.8. You prepare 50%, you get 50, 48 and 49. Yeah. You prepared 75, you get 75.9. Yeah. You prepared 100% of palm oil, you get 101. So this indicate that the software able to differentiate, able to predict their palm oil adulterant in olive oil lah. Okay. So the rest of it, okay, sekejap. Daripada situ, okay, no, yang tu boleh stop lah. Okay, thank you for sharing. Kita buka di, sekejap ya. We open back the, I will open about the Excel PowerPoint. Okay, so yang ni nampak ya. So from here again, barulah we compile the whole data that you have predicted. The one that you show, the one that you see here is the one that we have compiled. Yeah, because we have triplicate, so the one we prepared 0 palm oil, we get an average of -4.99. Yeah, so we prepared 25, we get 21.5 average value. Okay, so from here we conduct a Z test lah. Yeah, so from Z test, when the value of Z test is more than 0.05, the one that we set is 0.05. So you can see all of it, yeah, more than 0.05. You can see here, indicate the one that MLR predicted is not significantly different from the one that you have prepared. That will indicate the model that you have is really good in predicting the contaminant in your sample. Okay, so actually up to this slide, we have reached to the end of our workshop lah. Yeah. So before anything, do you have any questions so far?
So far at the chat box, no, not sure.
Okay. So everyone, actually we have reached to the end part, the last part of our multivariate analysis. Multivariate data analysis in food studies. So as a recap, for yesterday we learned about the prerequisite of multiple linear regression. And also multivariate data analysis in food study. We have removing the outliers, removing of missing data, treating of the having anomaly, and then we have to ensure the data that we have reach KMO value which is more than 0.5, and then we move to PCA, principal component analysis, identify the significant variable using factor loading. And then we can superimpose the variable plot and also observation plot. You can get a biplot, and from that biplot we can get or characterize or selecting which variable that characterize the sample itself. Yeah, and then we go to cluster analysis to complement the result of the PCA. Yeah, getting the result from dendrogram and profile plot. Yeah? And for today, we start with discriminant analysis, using the data, TAG data, triacylglycerol. We want to check whether the product that the sample that we have are really predicted according to their clusters. For the last session, we talked about multiple linear regression. The aim of it is to predict how much the concentration or the contaminant in our samples. So we learned about the statistic. We learned about training and testing data set. And then to evaluate, we go for goodness of fit statistic using R square, MSE, and RMSE. And then from there, we can predict your sample, unknown sample, and try to compare the significant difference between the predicted and actual value using the Z test. Okay, so I think that's all from me. Uh, if you have any problem related to your data set, you can come to us, to Inhad. Inshallah, we will assist you on providing our advice on how to analyze your data. We also offer, if you have want to have an online session so that we can see your data and then assisting you on that lah. I think that's all from me. If I have make some mistakes, perhaps the lackings coming from myself, anything good from Allah. Okay, so I hope that with this sharing of knowledge via this workshop will assisting us on how to use multivariate data analysis in giving a good decision in any activity that we have carried out. Okay, so back to you, Sister Alifah.
Okay, thank you so much, Dr. Shirwan. Okay, that means that our session for these 2 days is end here. Okay, so the thing that I need from you guys is actually the full name for e-certification issuance. And another thing, if you want me to post to you the original copy for the payment receipt, so you can drop a WhatsApp to me personally for your address, and I will post to you. Okay, I think that's all from us. Sorry for the inconvenience, any lacking throughout this workshop. So we are hoping that you will use this platform to you will use this platform in order to learn more for the multivariate analysis. So inshallah, you can text directly Dr. Shirwan for any question, further question later on. And we hope that to see you for our next workshop. We will post the workshop in our website for your further information, inshallah. So thank you from us, and hope to see you soon, inshallah. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you Nomi. Itulah saya tak sangka ni, saya rasa dia macam hang kot. It's okay. We need to comment.